Hi guys, welcome to Math Skills based on section 1. So in section 1, I've selected the math skills that appear on the side of the specification. So for first of the math skills, you need to be able to work out the pH if you know the concentration of hydrogen ions. So how to do it? You need to look on your calculator for log 10. And you also need to select the negative minus here because that's how you're going to use the formula. So the pH will be working out by minus log 10, and in the brackets you will put the concentration of the hydrogen ions that the examiner was given to you. So I found one of the questions here, which is to do with the concentration of hydrogen ions, but it's not necessarily to do with the pH. But it's still good to look at it because it's quite tricky. So the lactulose can also be used to treat people who have too high a concentration of hydrogen ions in their blood. And the normal range of blood of those hydrogen ions concentration is between 3.55 to 4.47, okay, times 10 to minus 8, okay, moles per decimeter cubes. But the patient was found with the concentration of 2.28 times 10 to minus 7. So you need to pay attention. You've got different standard forms here. So those are 10 to minus 8. Here we've got minus 7. So you need to calculate the minimum percentage decrease required to bring the patient's blood hydrogen ions concentration into the normal range. So looking at the standard the closest number that we could achieve from there is that one. So that will still be in the normal form, in the normal range of the hydrogen ions in the blood. So what we need to do, we need to find a difference between those two values. So 4.47 times 10 to minus 8, take away 2.82, which is the concentration of the patient's ions, times 10 to minus 7. That will give you a negative answer of minus 2.373 times 10 to minus 7. But that's only one working out to work out the difference between those values. But what they want from you, it's the percentage decrease. So percentage decrease, okay, we would look at our change. So minus 2.373 divided by the patient, which is 2.82. In this situation here, I didn't write the standard forms to 10 to minus 7 because both of those are 10 to minus 7, so they're going to close each other anyways. And I multiply this by 100 to get the percentage, which gives me a minus 84.1%. In terms of the answers, okay, that's the answer that you should achieve. They would accept this or 84, but those calculations here, okay, are obviously slightly different to what you would get on the final answer. So let's get going. And what's wrong with this here? Okay, so they wanted the obviously the minimum percentage decrease, so the use of the standard form here it's incorrect. So as I've shown you, okay, in my working out, you should start from there. That's the smaller number. That's what's going to give you that negative answer. Right, so another math skill here is that students should select the right format for the graphical presentation of the results of the investigation into the rate of enzyme control reactions. So I've selected a few questions here. One of those is the graph that shows you the results of the enzyme catalyzed reactions. So the concentration of maltose, so that means that starch is being hydrolyzed to maltose at the given time. And we also got another diagram to using the letters in the diagram describe what is happening in this reaction. So coming back to this, the questions, okay, were to explain the results. That's you remember, you cannot escape from the enzymes. So the rate of reaction here increase in the concentration of maltose, okay. So increase in the concentration of maltose, okay, slows as the substrate starch is used up. And that's correct because it does increase, but that increase slows here, okay. So they got the high initial rate, as we can see, because there is plenty enzyme substrate complexes. But after that 25 minutes, that point, what you can see, the graph levels off. So levels off, why? Because at starch, the substrate has been used up. And that's a really typical question. So make sure you are aware of the keywords, okay? And here we've got the diagram and using the letters describe. So say what you can see, obviously bringing the keywords, what is happening. So what we can see here, we've got D and E, okay. Stage 2, they join together, so forming enzyme substrate complex, okay. And then we're looking at the products. So we need to think which of those is actually the substrate, which are the products. So E or D. Well, E is an enzyme because as you can see, it didn't change at the end. So E must be a substrate and F and G are our products. So this is what you will then put in our answer. The enzyme D binds with substrate E. Active site forms changes slightly the shape due to induced feed hypothesis here. And enzyme substrate complexes are formed and the reaction gives you products F and G, so the enzyme stays unchanged at the end. So that's really important for your paper 1, definitely. So exam tips, another one for section 1, students could use a tangent to find the initial rate of the reaction. So obviously it's going to be difficult for me to draw a tangent here, but I will try my best. So we got a question here and it shows you the concentration of product against the time. So give one other factor that technicians could control. So in here would be, for example, the concentration of substrate or enzyme solution or pH, because they were looking at the temperature, hence we cannot provide temperature as the answer, or the concentration of product because that was checked as well. So calculate the rate of reaction at 25 degrees. This one is straightforward, really easy, because the rate of reaction will be change in Y over change in X. So what is the change in Y? Okay, so 10 to 0, so that gives you 10, and change in X from 240 to 0, so that's 240 as well. So that's your working out, but remember to include the units as well. So here we've got grams per decimeters cubed, and on that we had seconds. Okay, so once you've done this working out, you should get the answer of so we did decimeters cubed per second. Okay, so our answer is 0.04 grams per decimeters cubed per second. Then you have to describe and explain the differences between the two curves. Okay, for description, it's something that you can see. So we're looking at the initial rate, where is faster, where is slower, then why, explain. So here you're recalling the enzyme substrate complexes. Look at the ending curve here, so the levels of at what time and why. So you need to give the explanation for this as well. So the initial rate of reaction is faster at 37, which we've said. But look, initial rate, you need to say that. Why then? Because there is more kinetic energy, so more enzyme substrate complexes, and it levels off at 37 as well. At the 180 seconds, because all substrate has been used up. Typical question again. So one more here, we need to draw a tangent to calculate the rate of change